Hello students, I am Subhashish. In our previous session, we have learned to deal with problems of elevation and depression. Now, in this session, we will learn problems on both elevation and depression. Let us consider the following situation. A man standing at the top of a lighthouse located on a beach watches an aeroplane flying above the sea. At the same instant, he watches a ship sailing in the sea. The angle with which he watches the plane corresponds to the angle of elevation, and the angle of watching the ship corresponds to the angle of depression. This is one example where one observes both the angle of elevation and the angle of depression. In the above figure, x degrees is the angle of elevation and y degrees is the angle of depression. In this session, we try to solve problems when angles of elevation and depressions are given. Learning outcomes. At the end of this lesson, you will be able to understand how to solve problems involving angles of elevation and depression. Apply trigonometric principles to find heights and distances accurately. Develop problem solving skills for real life scenarios involving elevation and depression angles. Keywords from this lesson are observations, heights, angles, elevation, depression, distance, angle measurement, trigonometry. Let us see one example. From the top of a 12-meter high building, the angle of elevation of the top of a cable tower is 60 degrees and the angle of depression of its foot is 30 degrees. Determine the height of the tower. Solution. As shown in the figure, OA is the building, O is the point of observation on the top of the building OA. Then OA is equal to 12 meter. P dash is the cable tower with P as the top and P dash as the bottom. Then the angle of elevation of P, that is angle MOP, is equal to 60 degrees. And the angle of depression of P dash, that is angle MOP dash, is equal to 30 degrees. Suppose height of the cable tower PP dash is equal to h meters. Through O, draw OM perpendicular to PP dash. MP is equal to PP dash minus MP dash, that is equal to H minus OA, that is equal to H minus 12. In right triangle OMP, MP by OM is equal to tan 60 degrees. That gives H minus 12 by OM is equal to root 3. Tan 60 degrees is equal to root 3 from trigonometric table. By cross multiplication, OM is equal to H minus 12 by root 3. Consider it as 1. In right triangle OMP dash, MP dash by OM is equal to tan 30 degrees. Twelve by OM is equal to 1 by root 3. By cross multiplication, we get OM is equal to 12 root 3. Consider it as 2. From 1 and 2, we have H minus 12 by root 3 is equal to 12 root 3. Keep H in left hand side and all the other terms take it into right hand side. Then H is equal to 12 root 3 into root 3 plus 12. This we can write H is equal to 12 into 3 plus 12. that is equal to 48 meter. Therefore, the required height of the cable tower is 48 meter. Let us see one more example. A pole 5 meter high is fixed on the top of a tower. The angle of elevation of the top of the pole observed from a point A on the ground is 60 degrees, and the angle of depression to the point A from the top of the tower is 45 degrees. Find the height of the tower. Solution. Let BC be the height of the tower and CD be the height of the pole. Let A be the point of observation. Let BC is equal to x and AB is equal to y. From the diagram, angle BAD is equal to 60 degrees and angle XCA is equal to 45 degrees, that is equal to angle BAC. In right triangle ABC, tan 45 degrees is equal to opposite side by adjacent side, that is BC by AB. From the trigonometric table, tan 45 degrees is equal to 1. That gives 1 is equal to x by y. So, x is equal to y. Consider it as 1. In right triangle ABD, tan 60 degrees is equal to BD by AB. BD can be written as BC plus CD. So that is equal to BC plus CD by AB. From the trigonometric table, tan 60 degrees is equal to root 3. Root 3 is equal to x plus 5 by y. By cross multiplication, we get root 3y is equal to x plus y, consider it as 2. We get root 3x is equal to x plus 5 from 1. So x is equal to 5 by root 3 minus 1. Multiplying numerator and denominator by root 3 plus 1, we get 5 by root 3 minus 1 into root 3 plus 1 by root 3 plus 1. By simplifying, we get 5 into 1.732 plus 1 by 2. Then by solving, we get 6.83. Hence, height of the tower is 6.83 meters. Let us see another example. Three villagers A, B and C can see each other across a valley. The horizontal distance between A and B is 8 km and horizontal distance between B and C is 12 km. The angle of depression of B from A is 20 degrees and the angle of elevation of C from B is 30 degrees. Calculate the vertical height between A and B and the vertical height between B and C. Tan 20 degrees is equal to 0.3640 and root 3 is equal to 1.732. Solution. In right triangle ABD, tan theta is equal to opposite by adjacent side. Tan 20 degrees is equal to AD by BD. Tan 20 degrees is equal to 0.3640, that is given. 0.3640 is equal to AD by 8. AD is equal to 0.3640 into 8. By multiplying we get 2.91 kilometer. AD is equal to 2.91 kilometer. Therefore, the vertical height between A and B, that is AD, is equal to 2.91 kilometer. In right triangle CBE, tan 30 degrees is equal to CE by BE. From the table, tan 30 degrees is equal to 1 by root 3. Now 1 by root 3 is equal to CE by 12. By cross multiplication we get 12 by root 3 is equal to CE. Multiplying and dividing by root 3 we get CE is equal to 4 root 3 is equal to 4 into 1.732. By multiplying we get CE is equal to 6.93 kilometer. Therefore, the vertical height between B and C, that is CE, is equal to 6.93 kilometer. Summary of the lesson. The height or length of an object or distance between two distant objects can be determined with the help of trigonometric ratios. The angle of depression and angle of elevation are equal when viewing an object across a valley. Thanks for watching.